In this presentation, we are going to look at sigma notation. So the first thing we're going to do is we have this expression up here. Let S of n equals 1 plus 3 plus 5 and so on for all odd numbers where n is an element of the positive integers. This here indicates odd numbers. If you try that there, just like keep increasing your values of n, you get 2n minus 1, you get, for example, the next one would be the fourth one, 2 times 4 minus 1, that would equal 7, 2 times 5 minus 1, that will equal 9, and so on. So it's all the odd numbers, essentially. Okay, that's meant to be a u. Okay, just a quick remark, that means positive integers. N is any positive integer. Okay, then that sort of notation is always quite important. So the question here, the first question is, express S of n using sigma notation and then evaluate the first three terms. Then find a recurrence relation. We'll come back to that later on, actually, the recurrence relation. First off, let's express S of n using sigma notation. Well, it is written in terms of, so S of n is some unknown constant. It is the summation of all the intermediate values, and all the intermediate values we're going to call them 2i minus 1. We're not using n here, we use I, it's just because n is going to be reserved for something else. Now we're using sigma notation, and down here I is equal to 1. And we go, it sums from n, all the way up to n. So essentially what this means, I equal to 1, I equals 1 to n means I is equal to 1, 2, 3, all the way up to n. That's why we don't use n in here, because it just confuses things. So the sum of I from I to 1 to from I equal to 1 to n of 2i minus 1. Okay, so I just have that written again on the next slide. There we have it there. S of n equals the sum from I equal to 1 to n of 2i minus 1. Okay. The next one is evaluate S1, S2, and S3. Now I'm actually going to go a bit further than that. So first off, let's write in our indices here. So the first case is 1. Second case is 2, 3, 4. These are just the case numbers here. Now, S of n in each case, in this case is just simply 1. It's 1 plus 1. This is 1 plus 3 equal to 4. And this is 4 plus 5. That's 1 plus 3 plus 5. That's equal to 9. And the next one is going to be 5 plus 7 equals to 16. I'll actually add in one more. 7. The next one here is going to be 9. That would be 25. Okay. Now, what is just of interest here is the difference from each stage to the next. So here, what is the increase from here down to here? So it's actually 3. So the difference here is 3. So we add 3 onto the next one. From here down to here, the difference is 5. From 9 to 16, the difference is 7. And from 16 to 25, the difference is 9, and so on. So how does that relate to these values over here? Well, this is equal to, actually, do you know what? I'll just change that to n. I or n doesn't really matter now. How do these values over here relate to these values over here in this column? Well, in each case, it's actually equal to 2n plus 1. Okay. So what we could say about when n, S of n, let's say when that is n is equal to 1, S of 1 is 1, S of 2 is 4, and S of 3 is 9, and so on. But what does this 2n plus 1, what's that about? So I'm going to go back over here. I'm going to do this all now in this next slide here. So let's just recap on what I've said there previously. So n 1, 2, 3, 4. S of n was 1, 3, 5, and 7. And the difference between S of n plus 1, which is the next one, and, sorry, that's not them, that's 4, 9, and 16. Sorry, pardon me. Actually, I'll just rub that out and start again. So 4, 9, 16, and so on. So what's the difference? So between this one and this one, this is actually equal to Sn plus 1 minus Sn. That's equal to 3, 5, 7, and so on. And in each case, that is equal to 2n minus 1, 2n plus 1. Where n in this case is 1, n in this case is 2, n in this case is 3, and so on. So what we're saying is that the Sn plus 1 minus S of n equals 2n plus 1. So just rearrange that, we could say Sn plus 1 equals Sn plus 2n plus 1. Okay, and that is how we would answer this question. So it's looking at the sort of differences each time. There you have it there. Anyway, that ends our presentation.